A surge 22% brighter in a single second echoed through JWST's detectors before fading into perfect silence. A signal without a sender. A behaviour without a model. A new traveller arrived here at the exact moment the data stopped behaving like nature. What are the odds that an object from another star would carry a CO2 to water ratio of 8:1 a signature? No formation model can explain. What if the cosmos has been trying to tell us something quietly beneath the language of press releases? A light blinked once and was gone. Stay a while, traveller. Let's drift through the silence together. The first truth arrives not as a revelation but as a quiet shift in the data. When the James Webb Space Telescope was turned toward an interstellar wanderer, it was not done lightly. Time on that instrument is precious guarded, granted only when the cosmos whispers something worth listening to. And yet JWST was asked to study 3I Atlas, a visitor from another star, as if the universe had placed the object gently at the edge of our awareness. Its near-infrared spectrograph looked into the faint halo surrounding the nucleus and found something no model had prepared us for: a coma. Ruled not by water, but by carbon dioxide. Not similar quantities, not a gentle imbalance, an overwhelming ratio of 8:1. In comets born in our solar system, water leads carving its signature into centuries of observations. Here that order was reversed. The numbers sat plainly on the page, peer-reviewed and published, but the implications drifted quietly beneath them. What kind of world gives rise to such chemistry, and what journey must follow for it to remain so untouched? Tonight the universe whispers again, and the silence inside the question feels almost sacred. Scientists propose two explanations, both plausible on paper, and both strangely unsatisfying in their symmetry. One suggests a cradle far from the warmth of its parent star, a place where CO2 condensed more readily than water, sculpting the nucleus in a cold so deep it reshaped the familiar order of volatiles. The other imagines a region bathed in punishing radiation, where water ice was stripped away, grain by grain, until carbon dioxide remained as the dominant breath of the object. Each theory is possible. Each requires exceptional circumstances. Neither invokes anything supernatural, only the rare, the delicate, the improbable. Yet that is precisely why the discovery stirs something quieter than an alarm, a recognition that the cosmos contains histories we do not yet have the language to describe. JWST also revealed ice grains smaller than a micrometer, fine as powdered starlight, and their structure seemed amorphous, untouched by the heat that forces crystalline order. Ice like that forms at the far edge of possibility, and stays frozen in its ancient shape unless warmed by a sun. If this object still carries amorphous ice, then it has lived almost its entire existence in a darkness colder than imagination. Somewhere beyond our reach, something ancient still moves. Then came Swift's observation water sublimation, not close to the nucleus, but thousands of kilometers from its heart. Such activity so far from the inner surface challenges our sense of how comets breathe. Under sunlight, ice warms and vapor releases. The physics are simple, almost gentle, but here the distances stretch beyond typical explanations. Perhaps dust grains carried water outward before releasing it. Perhaps sunlight finds new paths through a structure we do not yet see. Whatever the cause, the behaviour unfolds with a kind of quiet defiance, as if the object is reminding us that our models are only approximations of a vast indifferent truth. None of this suggests fear. If anything, it suggests humility, an invitation to soften our certainty. Scientists can explain each anomaly individually as they should, but when the anomalies begin to echo when they form a pattern rather than a list, something shifts. The universe does not owe us familiarity. It does not promise repetition. It reveals what it reveals, drifting through the night with its own unfathomable patience. The gas production rates deepened the quiet mystery. In August, the Ursa Atlas released around 129 kilograms of carbon dioxide every second, but only 6.6 kilograms of water. The imbalance was not subtle. It was fundamental. A comet that exhales so strongly should feel the recoil. Thrust is not philosophical. It is Newtonian, simple, measurable. Yet orbital tracking showed almost no non-gravitational acceleration. The object followed its gravitational path with a steadiness that did not match the vigour of its outgassing. Two explanations emerge soft around the edges. Perhaps the nucleus is far larger and far more massive than initial estimates suggested. A mountain barely moves when a handful of snow slides from its face. Or perhaps the outgassing is balanced so perfectly across the surface that every force cancels every other. But symmetry of that purity is rare. Natural objects lean toward unevenness. They prefer irregularity. And so the analysis leaves us in a gentle pause, suspended between possibilities, learning once again that the cosmos is not obliged to simplify itself for our comfort. Listener, it's all right to not know. In these early observations, spectra grains, vapour motion, we find not a crisis but a meditation, a reminder that the universe is under no obligation to conform to our expectations, nor to provide answers on demand. NASA release the data faithfully as they must. The journals preserve every number, every uncertainty, every quiet contradiction. But the public statements smooth the contours, soften the edges, speak in tones meant to reassure, rather than provoke reflection. And so the deeper story is left to those who sit awake beneath the stars, tracing patterns in the faint fluorescence of distant ice. Tonight the stars will keep their silence, and we keep watch not for certainty, but for understanding that unfolds slowly like the turning of a distant orbit. When Spherex surveyed 3i Atlas in mid-September, its view expanded the silence rather than resolved it. A carbon dioxide coma stretching more than 348,000 kilometers across drifted outward from the nucleus, a cloud almost the size of the Earth-Moon distance. In most comets, CO2 appears as a supporting note, in a broader chemical chord present but secondary familiar, but modest. Here it took centre stage, filling space with a breath that felt ancient and untransformed. The scale alone was enough to slow the mind to invite a moment of stillness. Large comas are not unheard of, but their composition usually sings in water's voice. This one shimmered with something colder, something that seemed untouched by the thermal stories of comets born near familiar suns. Then the Very Large Telescope added its own quiet line cyanide, not in whispers, but in clear spectral strokes. CN radicals drifted through the cloud carrying the signatures of carbon-nitrogen bonds forged under distant stellar conditions. Organic chemistry unfolding in the dark is not unusual yet. Here it joined a pattern of deviations, each small on its own, each gentle, each patient, but together forming a mural we had never seen. The nickel vapour appeared next, and it felt like a soft rupture in what we thought we understood. Nickel is stubborn. It asks for heat, for pressure, for intensity before surrendering atoms to open space. For it to appear in the coma, metallic grains deep within the nucleus must have warmed enough to release heavy atoms into the surrounding void. Such detections occur in rare instances with solar system comets, but those are exceptions, fleeting deviations from the expected. For 3i Atlas, it was another piece of a story already leaning into unfamiliar territory. Metals in its breath, organics in its cloud, carbon dioxide in overwhelming measure, each fact rested quietly, refusing drama, yet refusing simplicity as well. The James Clerk Maxwell telescope followed with measurements that felt almost alive, hydrogen cyanide production tripling in a single week. Activity in comets can rise sharply near sunlight, but the rapid change here suggested layers opening vents, awakening structure, shifting in ways that left even experienced observers pausing before their conclusions. None of these measurements announce catastrophe or danger. Instead, they announce complexity, the kind that unfolds slowly with the patience of a world shaped far from ours. Silence is the language of distant worlds, and in this silence the chemistry spoke in accents we were still learning to hear. Researchers turned to comparisons as they must. Only one other interstellar comet 2i Borisov had offered itself to detailed study. Its composition aligned cleanly with expectations, water-dominated dust, rich behaviourally, familiar despite its interstellar origin. If Borisov was a message from a cosmic neighbourhood not unlike our own, then 3i Atlas felt like a message from somewhere more remote, where formation and evolution follow paths rarely mirrored in local star systems. That is not a breach of natural law, it is a reminder of nature's diversity. Each detection CO2, cyanide, nickel fit within physical principles, Yet together they sketch the outline of a birthplace with properties that do not map neatly onto our existing frameworks. Some researchers suggested that planetary systems might produce multiple families of interstellar comets, each bearing the signature of its home. Others pointed out that the differences between Borisov and Atlas hint at deeper divergences in stellar chemistry, disk temperature, and early dynamical history. None of these ideas claimed certainty. They merely held their hands open to the unknown. And there, in the midst of these possibilities, another quiet thread pulled at the edges the lack of measurable non-gravitational acceleration. An object releasing over 100 kilograms of gas each second should feel it move by its shift because of it. Yet 3I Atlas glided as though carried only by gravity's gentle arc. Perhaps its nucleus is vast and heavy. Perhaps its vents form a symmetrical chorus. Or perhaps we're being shown that the universe sometimes arranges its objects in ways that resist our expectations. Tonight, the universe whispers again. As the coma brightened and the data deepened, the questions grew softer, not louder. They became reflections rather than alarms, meditations rather than warnings. Size remained the quiet anchor. Without it, every interpretation drifted. If the nucleus is small, the gas release becomes extraordinary. If it is large, the absence of acceleration becomes natural. Observers on Earth could not yet resolve the core, only the glow surrounding it, light diffused through dust refracted through ancient ice. And so the measurements remained a spectrum of possibilities rather than a conclusion. Through all of this, the object moved steadily along its hyperbolic path, indifferent to the attention it received. It offered its chemistry without explanation, its behaviour without commentary. It simply existed, carrying the memory of a distant system through our own. And perhaps that is why this interstellar visitor feels less like an anomaly, and more like a reminder that our models, though elegant, are not prescriptions for the cosmos, only approximations drawn from our small corner of space. It's all right to not know. The sky holds room for uncertainty. The stars do not rush to correct us. They wait patient and distant while we learn to listen with quieter minds. The orbit of 3I Atlas revealed its quiet strangeness long before theories appeared. It followed a hyperbolic path eccentricity, 6.2 entering and leaving our solar system without intention of return. Its speed, 58 kilometers per second, spoke of distances older than Earth itself. Yet the 5-degree tilt from the ecliptic combined with retrograde motion made astronomers pause. Rarity here felt less like warning, and more like the universe gently raising an eyebrow. Probability softened rather than sharpened the mystery. A 1 in 20,000 alignment remains natural when the stage is cosmic in scale. Statistics do not shout in astronomy. They whisper, acknowledging that improbable things still occur in the quiet spaces between stars. Atlas settled into that whispering category, a visitor that just happened to cross the planetary plane in an elegant, unlikely sweep. Nothing demanded alarm, only patient reflection on how vast possibility truly is. The absence of non-gravitational acceleration drifted through every model like a subtle contradiction. With more than 100 kilograms of gas escaping each second, the object should have felt some gentle push. Yet its motion remained unchanged, held only by gravity's hand. Perhaps it was larger than early estimates, allowed dense enough to ignore its own breath. Or perhaps its outgassing was balanced in a way nature rarely arranges. Neither explanation broke physics. Both rested quietly in uncertainty. Comparisons with Borisov softened the edges of interpretation. Borisov behaved like a familiar comet wearing unfamiliar origins, its chemistry fitting neatly into established patterns. Atlas did not. Its unusual ratios and silent acceleration suggested conditions carved by a different kind of star, a different temperature gradient, a different story. The universe creates not one kind of wanderer, but many, each carrying the imprint of a birthplace we may never see, the sequence of distant passes. Venus, Mars, Jupiter formed another quiet footnote. The encounters were too wide to matter gravitationally, yet close enough to draw attention. Patterns like these appear meaningful only when viewed in hindsight, painted with human intuition. In truth, the path was simply one possibility, among countless geometric threads the cosmos could have woven. Random, gentle, and still strangely beautiful, As perihelion approached, the object slipped behind the sun, entering a stretch of sky where observation becomes impossible. Ground telescopes waited in enforced silence, their vision washed out by solar brightness. Only a few spacecraft in wandering orbits might glimpse its passage, their instruments facing the sun's harsh glow. For a time, the comet existed beyond visibility, reminding us that astronomy often lives in intervals of waiting. When Atlas emerges from the sun's glare, the nature of its orbit will speak more clearly than speculation ever could. A shift even delicate would echo across the measurements with unmistakable grace. A perfect gravitational path would settle the question into gentle certainty. Either outcome invites acceptance rather than urgency. The cosmos unfolds without haste, and so must those who watch it. For now, the orbit remains a meditation, steady, quiet, and transparent only in the ways it chooses to be. The object moves as all wanderers do, carrying the memory of its origin without explanation. In that movement lies the essence of astronomy, patient observation, calm uncertainty, and the quiet knowledge that not all mysteries are problems to be solved. Some are simply stars passing through the dark. When astronomers pointed Hubble toward 3i Atlas, they hoped for clarity, for a glimpse of the nucleus buried inside the bright haze of its coma. Instead, the object dissolved into a soft blur, a glow without a centre, a light that refused to sharpen into form. Estimates expanded across an immense range, anywhere between 0.3 and 5.6 kilometers across. A 17-fold uncertainty is not common even in the patient world of comet study, and the scale of that uncertainty became its own quiet mystery. The difficulty lay in the very structure of comets. Their nuclei hide behind dust, scattering sunlight in ways that distort brightness and shape. To discern the solid core beneath the glow, scientists rely on models' assumptions about dust size, reflectivity, and gas production rates. Adjust one assumption and the entire solution shifts. Atlas seemed to drift through every model, like a soft contradiction, offering light without form, presence without edges. It felt as though the universe had cupped the object, gently shielding its true size from our instruments. A small nucleus under a kilometre would imply something remarkable, that an object so tiny could release such enormous amounts of carbon dioxide and cyanide. Its activity would be far more intense than typical comets, its size almost excessive for its mass. A larger nucleus, however, 5 or 6 kilometres across, would allow for heavy inertia, making the lack of measurable acceleration perfectly natural. And yet that size introduced another question. How does an object so large become an interstellar traveller at all? Large bodies resist ejection. Their mass anchors them to the gravity wells of their home systems, making escape rare without dramatic interactions. To find such an object here drifting through our inner solar system felt like a quiet improbability. Not impossible, simply unusual. Unusual enough that astronomers leaned back in their chairs and allowed themselves a moment of stillness, acknowledging that each new measurement opened rather than closed the mystery of the object's origin. The range of possible sizes became the hinge on which countless other questions hung. How much mass was the comet losing each second? How many centuries or millennia had it been active? How fragile or resilient was its structure as it approached the sun? These questions all circled a single unknown, the volume of the hidden world beneath the coma. Without size, every answer drifted like dust in sunlight. Size was the anchor, and the sky refused to give it. Models of outgassing too folded back onto the size question. A small body with violent release rates would fragment easily under thermal stress, yet Atlas remained whole. A large body warming from within could sustain deep subsurface activity without tearing itself apart. Each interpretation felt true for a moment, then softened, faded, and dissolved. It became clear that the data did not contradict itself. It simply spoke in a dialect of uncertainty. The Mars flyby offered hope that the veil might finally lift. ExoMars' Trace Gas Orbiter turned its delicate instruments toward the faint glow, hoping to resolve structure against the dark of space. But even from that vantage, even across 28 million kilometers, the nucleus remained hidden inside its halo. High-resolution cameras captured only the outer breadth of the object, not the heart. The glow thickened, but the silhouette stayed concealed. Some expected Perseverance to capture it. Its cameras had surprised us before with glimpses of passing stars, planetary conjunctions, and rare sky events. But no official images appeared. Rumours drifted across forums and message boards, each claiming a glimpse, each unsupported by data. NASA remained silent, and silence, though natural in scientific pacing, allowed imagination to fill the void. In the absence of clarity, the size mystery grew softer but deeper. The absence of resolution became an unintentional lesson in humility. We live in an era of extraordinary instruments, JWST peering through cosmic dust, ALMA tracing shapes in molecular clouds, Hubble drifting above the atmosphere with decades of precision behind it. And yet, a single visitor from another star eluded direct measurement. The universe in its quiet way reminded us that not all truths yield simply because we ask. Every telescope that observed Atlas added data, but not answers. Brightness curves, spectral shapes, dust profiles, gas production, all spoke clearly, all offered pieces, but none revealed the core. It felt as though the comet were wrapped in a cloud that thickened in exact proportion to our attempts to see through it. A reminder that sometimes knowledge arrives not through persistence, but through patience. As the comet approached perihelion, the question of size intertwined with the question of survival. Smaller comets often fracture near the Sun, unable to withstand the heat and gravitational tension. Larger comets endure shedding layers, but remaining whole. Without knowing the nucleus size, astronomers could only watch the predictions overlap. Would Atlas fragment in sunlight? Would it brighten suddenly or flare or quiet? The sky offered no preview, no hint. When through Atlas slipped behind the Sun, the size question followed it into the silence. Observations ceased. Light curves flattened. Instruments turned instead to the rhythms of the solar corona. For a few days, the interstellar traveller existed entirely beyond our sight, carrying its secret through a corridor of fire. And in that interval, the uncertainty felt almost peaceful, that not knowing can itself be a kind of stillness. As Atlas emerged again from the Sun's glare, scientists prepared once more to measure its brightness, its dust output, its spectral fingerprints. A change in brightness could hint at loss of mass. A shift in dust grain size could suggest internal fractures. Every clue would circle back to the size they could not see. In the end, the nucleus remained an enigma light without body form, without outline. Perhaps that is the quiet lesson of Atlas, that some cosmic travellers guard their core not out of defiance but out of nature. Not all stories arrive fully open. Some reveal themselves through patterns, through echoes, through the spaces between measurements. And the size of this interstellar wanderer, whether small or immense, exists not as a missing fact, but as an invitation. A reminder that the universe does not rush its truths. Night after night, telescopes trace the visitor's arc across the sky. The coma expands, contracts, brightens, fades. The tail drifts like a quiet thought across the stars. And still the nucleus remains unseen, leaving behind not frustration, but a moment of acceptance. The cosmos shows what it chooses. The rest unfolds in time. Tonight the stars hold their silence, and that silence is enough. After the Mars flyby, astronomers prepared for clarity, yet what arrived was a deeper quiet. ExoMars had traced the coma with patience, capturing brightness texture, and the faint plume of gases escaping into space. But the nucleus remained concealed, folded inside its own halo of dust, as if distance and light conspired to protect it. Each new image added detail to the cloud, but none to the body within it. The core of 3i Atlas stayed untouched by direct measurement, a presence without shape. Across observatories, researchers compared the data in soft, deliberate conversations. There were no contradictions, only absences, places where equations faltered, because the missing variables still drifted beyond reach. The coma behaved as expected for a highly active object, yet the object at its centre refused to reveal its boundaries. Every instrument confirmed activity, but none confirmed scale. It was a rare kind of silence, not the absence of information, but the presence of mystery. Speculation appeared quietly in the corners of astronomy forums where small fragments of rumour settled like dust. Mentions of possible Perseverance sky images surfaced briefly, their origins uncertain, their authenticity unverified. Nothing in them offered clarity, only questions softened by ambiguity. NASA issued no statements, not out of secrecy, but out of the ordinary pacing of mission workflow. In the stillness, imagination grew not wild, not fearful, just curious, hungry for shape. GOES 19 entered the narrative with similar softness. Weather satellites sometimes capture unintended glimpses of celestial motion when angles align in improbable ways. Reports suggested that during solar conjunction, GOES 19 may have recorded faint signatures of the interstellar visitor, but no images appeared, no confirmations followed, and the sky remained without commentary. Silence accumulated gently around the event like frost on a window before dawn. To astronomers, this quiet was familiar. Spacecraft data does not arrive fully formed. It emerges through calibration pipelines, stripping noise, adjusting exposure, removing artifacts. Each step requires time, and time in astronomy stretches differently than it does in public expectation. 3 Atlas followed this slower rhythm, as though echoing the pace of the instruments watching it. What the public perceived as delay, scientists recognized as process. Yet perception itself influenced the unfolding story. The public saw the scientific papers, the spectra ratios, uncertainties standing beside press releases trimmed to simplicity. What journals describe as unresolved questions, official statements often soften into cautious phrasing. This difference is not deception, it is translation. But translation sometimes blurs the edges of truth. With Atlas, those blurred edges invited contemplation rather than clarity. In academic circles, researchers reflected on this tension. How should agencies communicate when the data is remarkable yet incomplete? How do you preserve the wonder of discovery without implying certainty that does not exist? 3 Atlas became a quiet case study in communication, how silence can be misread, how ambiguity can be mistaken for omission. The object itself remained unchanged. The discourse surrounding it shifted like drifting dust. Some pointed out that the heightened curiosity around Atlas was itself a sign of progress. People cared deeply about a visitor from another star. They followed spectral lines, brightness curves, orbital plots, discussing them with genuine engagement. Curiosity, even imperfectly informed, is not a threat to science, it is its companion. The presence of unanswered questions was not a flaw, but an invitation into the unfolding mystery. Meanwhile, ground-based observations continued measuring the brightness of the coma as the object drew closer to the Sun. Each uptick or dip in magnitude sparked re-evaluation of earlier assumptions. A slight increase might hint at new vents opening on the surface. A decrease could suggest dust settling into equilibrium. But none of these measurements revealed the nucleus, the silent architect of all visible behaviour. It remained hidden behind its luminous breath. Scientists attempted indirect methods to narrow the size, modelling the heat flux, estimating surface area from production rates, comparing dust to gas ratios. Each method produced answers, but the answers contradicted one another. A small nucleus fit the gas production but strained the expected structural stability. A large nucleus matched the absence of acceleration, but strained the known ejection models for interstellar bodies. The truth lived somewhere between equations, like a shadow cast by competing lights. Alongside the scientific work, a philosophical thread emerged. Not every cosmic question offers immediate resolution. Some unfold gradually, like the cooling of a star or the spreading of a nebula. Atlas reminded observers that the pursuit of knowledge is not a race toward answers, but a slow walk through the unknown. In this sense, the hidden nucleus was not an obstacle, it was a teacher. It taught patience and humility in equal measure. As solar conjunction approached, telescopes turned reluctantly away. The sun's brightness overwhelmed even the most powerful detectors, washing the object from the sky. For a time, the interstellar visitor lived entirely behind the solar curtain, its activity invisible, its evolution unobserved. This period felt both frustrating and peaceful, a forced pause, a celestial breath, a moment when nature asked us to step back. During this silence, models ran continuously. Some predicted fragmentation near perihelion, others predicted stability. Without the size of the nucleus, no model held dominance. The cosmos, indifferent to the debate, continued its motion. And in that indifference there was a strange comfort. The universe does not hurry its revelations, nor does it struggle to be understood. When Atlas finally re-emerged from the sun's glare, astronomers prepared again to measure its brightness. If it had fractured, the light curve would show it. If it had survived intact, the dust profile would remain smooth. The first signals trickled in soft, faint, shaped by distance, and once more the nucleus remained hidden. The enigma persisted with gentle consistency. By now, the uncertainty itself had become a form of knowledge. The unresolved became meaningful, not frustrating. Not every celestial object arrives as a solved equation. Some arrive as meditations. Atlas taught observers to carry questions without urgency, to study not just data but the space between data points. It showed that wonder can arise from incomplete understanding, and that beauty often lives inside what we cannot yet define. In the end, the story of the missing nucleus did not weaken the object's scientific value. It strengthened its poetic one. Atlas drifted through our sky not as a puzzle demanding solution, but as a reminder of how vast the unknown remains. The silence around its core became a gentle echo in the minds of those watching, and as night returned to the observatories, the cosmos whispered that some mysteries are meant to unfold slowly. Some truths arrive only when the universe is ready to reveal them. The question of non-gravitational acceleration lingered in the background of every discussion about 3I Atlas. Comets release gas as they warm, and that release acts like a network of small thrusters, pushing gently on the nucleus. Even modest venting usually alters a comet's path, shifting its predicted arrival times by minutes, sometimes hours. Yet Atlas moved as though no such forces touched it, following a curve defined only by sunlight and gravity. This calm obedience to gravitational motion felt unusual, not because it broke physics, but because it whispered of unseen properties beneath the coma. Astronomers approached the anomaly with restraint. The simplest explanation was mass, a large nucleus dense and heavy enough that outgassing created almost no measurable push. A mountain does not move when a gust of wind touches its surface. But estimates of Atlas's size varied widely, and without a clear measurement of the core, the mass remained an open question. A small body should wobble under the influence of its own escaping gases. A large body should glide through space with inertia as its shield. Atlas seemed to behave as if leaning toward the latter. Symmetry formed the second explanation. If outgassing occurred evenly across the nucleus, the thrust vectors would cancel, leaving no detectable acceleration. But comets rarely express such balance. Their surfaces are shaped by uneven heating fractures, pockets of ice, and deep cavities revealed at random. Perfect symmetry feels more like a fleeting moment than a sustained condition. Atlas kept that moment alive for months, as though each breath it released into space was mirrored by another on the opposite side. In academic circles, the conversation drifted naturally toward nuance rather than conclusion. Papers explored the consequences of different mass assumptions, running simulations that varied dust production, thermal conductivity, and rotational states. Each simulation produced a version of Atlas that could exist, yet none offered certainty. This was not failure. It was the quiet unfolding of scientific thought. The object was teaching researchers something subtle, that the unknown often resists collapse into a single interpretation. Beyond the orbital mechanics lay something more philosophical. Science at its core accepts ambiguity as part of its language. The absence of acceleration did not mean intention. It did not demand speculation beyond physics. It simply existed, a condition shaped by mass geometry or thermal history. Yet the public imagination, eager for clarity, often saw silence as a mission. Researchers aware of this divide spoke carefully, allowing the data to breathe without forcing it into premature shape. As Atlas approached perihelion, the world turned toward the part of its orbit where the greatest activity was expected. Solar heating would rise, gas production would peak, and any imbalance, no matter how small, could appear in the trajectory. The moment felt delicate. This was not a climax, but a quiet test, a place where nature might reveal the deeper structure of the visitor, yet Earth-based telescopes would not witness it. The sun's glare swallowed the object completely, placing the most revealing moment behind a curtain of light. solar spacecraft offered faint hope. Parker, Solar Probe and Solar Orbiter drifted through their orbits with instruments oriented for studying solar wind magnetic fields and coronal structures. If Atlas crossed their fields of view even briefly, even incidentally, they might gather precious measurements. But mission operations follow strict priorities, and no announcements confirmed any coordinated observations. Astronomers waited not for images, but for the possibility of images, a quieter form of anticipation shaped by patience rather than urgency. In that anticipation, a deeper truth surfaced. Astronomy is built on the willingness to wait. Stars evolve over lifetimes. Orbits unfold over centuries. Even the arrival of light itself is delayed by distance. Through Atlas, the public encountered this rhythm directly a moment when the most important data slipped temporarily beyond reach. Instead of a dramatic revelation, there was simply the passage of time, steady as an orbit around the Sun. When the object emerged again from behind the solar disk, telescopes recalibrated and turned toward its expected position. There was calm in this return, a gentle recognition that the sky had resumed its visible conversation. Initial reports focused on brightness, whether Atlas had survived perihelion intact or shed fragments under the pressure of solar heat. Each small variation in luminosity carried meaning hinting at structural integrity or subtle loss of mass. The comet remained whole, and its orbit remained nearly unchanged. This persistence invited a renewed reflection on the earlier anomaly. If outgassing had intensified near perihelion, yet no measurable acceleration appeared afterward, the argument for a larger nucleus grew stronger. A heavy object moves through space with the steadiness of a drifting world, not the flutter of a fragile body. Atlas behaved like the former quiet in its motion, unbothered by its own activity. It passed through the inner solar system with the calm of something shaped in deeper cold and deeper time. Observatories monitored its outward arc, watching the dust tail thin and the coma shrink as the visitor retreated from heat. Each data point felt like the closing of a chapter in a book written partly in light and partly in uncertainty. Atlas was becoming faint again, not because it had changed, but because distance had taken its usual place between us and the unknown. The further it travelled, the quieter its signature became. Even as the object faded, the conversations it sparked did not. Scientists continued to debate the connection between mass symmetry and orbital behaviour. Some leaned toward a heavy nucleus pointing to the consistency of the trajectory. Others allowed for the possibility of structural properties that had no analogue in solar-borne comets. And many simply acknowledged that the interstellar origin of the object freed it from our expectations. Different systems produce different rules, and different rules produce different wanderers. It becomes clear with time that Atlas's story is not defined by the absence of acceleration, but by the presence of possibility. It is a reminder that cosmic objects are not bound to conform to the shapes we predict for them. They are artifacts of environments we cannot see sculpted by histories we cannot witness. Their motion is not meant to satisfy our models. Our models exist to follow their motion. As Atlas moves toward the darker edges of the solar system, the mystery surrounding its quiet orbit becomes something softer than a puzzle. It becomes an expression of the universe's calm indifference to our certainty. The object is what it is: steady, distant, ancient, and our attempts to define it are part of our own unfolding story, not its own. In that recognition lies a gentle peace. Tonight the interstellar visitor continues outward, leaving behind a wake of data shaped as much by silence as by light. Nothing about its motion demands urgency. Nothing about its path insists on revelation. And in its quiet trajectory we find again the simple truth that not all mysteries exist to be solved. Some drift across our sky to remind us of humility, of patience, and of the vast unhurried rhythm of the cosmos. The orbital geometry of 3i Atlas carried its own quiet signature, subtle yet persistent. As astronomers traced its path backward through space, they found a sequence of planetary proximities. First Venus, then Mars, then Jupiter, each distant enough to avoid gravitational influence, yet close enough to be noticed. These encounters, spread across millions of kilometers, formed a delicate chain of alignments. Nothing dramatic, nothing impossible, just uncommon. And in astronomy, uncommon is simply another way of saying the universe is wider than our expectations. When researchers calculated the statistical likelihood of these alignments occurring in sequence, the probability hovered around 1 in 20,000. A small number, but not a startling one when measured on cosmic scales. Over billions of years, the improbable becomes routine. The universe deals in vast sample sizes. What seems unlikely in the language of human intuition is almost inevitable in the language of celestial mechanics. Atlas moved through this space of probability with quiet indifference, following a path that was remarkable only because we happened to witness it. Still, the geometry stirred deeper curiosity. Hyperbolic visitors arrived from every imaginable angle, yet Atlas passed through the ecliptic plane with surprising precision. 5 degrees above the planetary sheet is not unusual, but moving retrograde adds a layer of symmetry that feels almost artistic. Retrograde motion is nature's reminder that direction is not preference, only geometry. Atlas did not defy the system. It simply entered it from another perspective, tracing a path that mirrored the planets while moving against their flow. Scientists studying these alignments recognized a familiar tension between pattern and perception. Human minds are drawn to sequences. We search for intention even in randomness. But celestial mechanics offer no hidden motive, only consequence. Atlas approached Venus not because it sought the planet, but because gravity had sculpted its incoming trajectory long before it reached our sky. The closeness to Mars and Jupiter followed naturally each encounter, a byproduct of entry angle and velocity. The pattern was real, but the meaning remained our own projection. The perihelion timing added another layer of reflection. Atlas reached its closest approach to the Sun during solar conjunction, a period when it became invisible to Earth's instruments. The coincidence felt deliberate, only in the way shadows feel deliberate when the sun sets behind a mountain. Geometry creates its own rhythms, and Atlas followed one of them. The moment of maximum activity unfolded behind a curtain of light, hidden not by mystery but by the ordinary brilliance of our star. Researchers traced hypothetical paths for the object-running simulations through the gravitational tides of the Milky Way. They found 100 potential birthplaces and 1,000 potential ejection events, interactions with young planets passing stars, or turbulent molecular clouds. None of these histories were definitive, yet each offered a glimpse of how easily an object might transition from a bound orbit to an interstellar drift. Atlas followed this ancient script shaped by forces long forgotten, carrying the chemistry of its origin across the gulf between stars. The community's reflections expanded into broader questions. What does probability mean when dealing with only the third interstellar visitor ever studied? How do we interpret rarity when our sample size is small enough to count on one hand? Statistical reasoning becomes a meditation rather than a conclusion. With only 2 previous interstellar comets known, any new arrival rewrites the curve. Unusual behavior is not a deviation. It is data redefining what normal might eventually become. Through papers and conferences, astronomers discussed Atlas with a tone that mixed caution with reverence. They approached the object not as an anomaly to be corrected, but as a messenger of new possibilities. Each unusual feature, its composition, its acceleration profile, its orbital geometry, became a reminder that we are standing at the beginning of a field, not the middle. Interstellar astronomy is still young. Its rules are still forming. And Atlas gently nudged those rules outward. The geometry of the orbit also highlighted the quiet impartiality of the universe. Atlas passed near multiple planets but interacted with none of them. It did not alter their orbits, nor did they alter its. Gravity offered no dramatic gestures, only the slightest adjustments too small to matter. The comet moved onward unaffected, like a thought passing through the solar system, without disturbing its surface. This absence of interaction reinforced the idea that Atlas was simply drifting part of a larger cosmic current. Even the thought experiments surrounding its trajectory remained grounded in patient science. Researchers explored what alternative histories might look like, not as claims, but as ways to map the boundaries of possibility. If Atlas had encountered a binary star, what would its velocity distribution resemble? If its formation disk were carbon-rich, how would that shape its chemistry? The work was not speculation, it was exploration. a mathematical expedition into worlds we cannot see. As the comet continued outward, leaving the planetary region behind its orbit stabilized into a clear map of the future, it would not return. It would slip back into the interstellar medium, carrying traces of our sun in its dust, just as it carried traces of its home system when it arrived. The solar system leaves faint fingerprints on every visitor, subtle chemical and thermal memories that linger long after the encounter ends. Atlas would drift on with that new history, etched into its surface, becoming slightly less foreign and slightly more universal. In the end, the geometry of its path became less a puzzle and more a poem, an arc of motion shaped by forces older than memory. It crossed our sky not to challenge our understanding, but to extend it. The rare became ordinary in its presence. The improbable became simply another note in the universe's long, patient composition. And as the object moved beyond Mars, beyond Jupiter, and into the quiet beyond planetary influence, its trajectory settled into a truth that astronomy has always known: nothing in the cosmos is truly out of place. Tonight, Three-Eye Atlas continues its outward drift, its path steady, its silence intact. The sky holds no urgency for answers, and the universe offers no explanation beyond the gentle movement of its laws. What remains is geometry carved into starlight, a shape defined not by intention, but by cosmic circumstance. And in that shape we find a quiet reminder of our place within the vast, unhurried rhythm of space. As observations accumulated across continents, a quieter pattern emerged, one not in the data itself, but in the spaces between institutions. NASA, ESA, and national observatories around the world each held pieces of the story of Three Atlas, yet their public communication unfolded slowly like a dim star rising above the horizon. Press releases offered fragments each technically accurate but stripped of the nuance found in journal papers. Between these fragments lay a silence that shaped perception as strongly as the data did. Astronomers reading preprints saw honest debate, uncertainty about size questions, about acceleration recognition, that the object's chemistry challenged existing models, but the public saw only a simplified narrative softened to avoid misinterpretation. This is the nature of communication inside large agencies. Clarity over complexity, restraint over speculation. Yet with Atlas, that restraint left wide spaces where curiosity could echo unchecked. Silence, even unintentional silence, has its own gravitational pull. ESA's updates followed a similar cadence. ExoMars confirmed the coma's extent, its brightness, and the difficulty of resolving the nucleus, but little more. The absence of follow-up did not signify withholding. It reflected the slow rhythm of data processing, calibration, and analysis. Still, the public sensed incompleteness. Atlas was a visitor from another star. People wanted real-time answers, not careful fragments spaced weeks apart. The pacing of science felt suddenly out of sync with the pacing of human imagination. International coordination, though present behind the scenes, rarely translated into unified public messaging. Each agency communicated through its own procedures, its own risk assessments, its own thresholds for certainty. This produced an unintended effect. The story of Atlas felt scattered, as though the sky were speaking through many small windows instead of one clear pane of glass. Information arrived in currents rather than streams, shaped by institutional boundaries rather than the object itself. Inside scientific communities, the tone remained calm. Researchers understood the workflows, the timelines, the caution that guides public statements. They knew that data moves slowly, not because of secrecy, but because precision requires time. Yet outside those circles, the quiet felt heavier. People sensed that scientists were discussing the object with more complexity than agencies were acknowledging. This contrast, subtle but persistent, created an aura of withheld context, even where none existed. The concept of uncertainty is treated differently inside and outside science. For researchers, uncertainty is the starting point, a natural condition of early observation. For the public, uncertainty often feels like a mission, like a gap that should be filled but hasn't been. Atlas magnified this difference. Its interstellar identity made every unanswered question feel larger, even though unanswered questions are the soil from which scientific understanding grows. Some noted the contrast between the open discussions in preprint archives and the minimal tone of official communications. Papers explored possible origins, formation models, and chemical pathways. They acknowledged that the CO2 ratios, cyanide levels, and nickel vapor suggested an environment unlike any we have studied closely. Meanwhile, press releases focused on the basics, discovery, trajectory, observational milestones. Both were accurate, neither was wrong. Yet together they created a sense of imbalanced detail without context without detail. This difference was not deliberate, it was structural. Communication officers in space agencies are tasked with avoiding unnecessary alarm, resisting speculation, and maintaining public trust. Technical nuance is often softened to prevent misinterpretation. But with an object like Atlas, where the anomalies were subtle, but numerous softening, the message made the story feel smaller than the science. The wonder remained, but the depth felt muted. As solar conjunction approached, this communication gap widened. Observers knew the object would be unobservable for weeks. Agencies acknowledged it briefly, but did not elaborate on how crucial that window was to understanding activity near perihelion. In scientific circles, this window was a point of focus. Models diverged most sharply during this phase. Yet the public narrative barely touched it, leaving people unaware that the most revealing moment was unfolding beyond sight. International collaboration existed, but silently. Telescopes in Chile, Hawaii, the Canary Islands, and Europe passed data into shared repositories. Analysts from multiple institutions compared spectroscopic signatures, brightness, curves, and dust models. This quiet cooperation is the backbone of modern astronomy. Yet because it remained unspoken, many assumed agencies were working in isolation. Atlas highlighted how invisible collaboration can sometimes appear as fragmentation to those outside the field. As the comet approached the inner solar system, public curiosity grew faster than institutional communication could satisfy. Questions multiplied. What was its true size? Why no acceleration? Why so much carbon dioxide? Agencies were not withholding answers, they simply did not have them. The comet itself provided no finality, only hints. Still, the pace of official updates remained measured, cautious, sometimes months behind new insights appearing in academic discussions. In the background, researchers reflected on this dynamic. They wondered how to maintain scientific rigor while engaging the public with honesty and nuance. They recognized that the world had changed. People now follow preprints, join telescope live streams, and pass orbital data on social media. The boundary between expert and observer has thinned. Atlas made this visible. It asked whether communication practices born in an earlier era still fit a world where curiosity flows instantly and globally. Space agencies face constraints that scientists do not. Public statements must be vetted, risk assessed, and approved. They must avoid speculation even when speculation is the air scientists breathe. With Atlas, the agencies chose caution. The scientists chose open inquiry. The public saw both streams at once and felt the tension between them. Not tension of conflict, tension of tempo. What emerged was not distrust, but a reflection on how knowledge moves. Atlas travelled through the solar system with grace, carrying chemistry dust and ancient memory. Our institutions moved more slowly, bound by procedure, shaped by caution. Between the two lay a space-wide quiet and filled with the pause of unanswered questions. That space became part of the story as essential as the spectral lines or the orbital plots. As the comet receded toward darkness, the conversation shifted again. Agencies resumed their steady updates. Papers matured into peer-reviewed form. The sky, no longer obscured by the sun, returned the visitor to our instruments. Slowly, clarity began to grow. Yet the lesson remained silence, and science is not emptiness. It is a stage in understanding, a quiet shade where new interpretations take shape. In the end, Atlas revealed not only its own nature but our own. It showed how humans chase meaning through data, how we listen for truth both in what is said and in what is not. It reminded us that discovery is not a single moment of revelation, but a long unfolding one shaped by collaboration, caution, curiosity, and the vast, unhurried rhythm of the cosmos. Tonight, the silence remains gentle and the story continues. As October 29th approached, 3I Atlas drifted toward the narrow arc of its orbit closest to the sun, the place where heat rises like a quiet tide. Comets often reveal their true nature here, shedding dust, exposing ancient layers, brightening under the sculpting hand of sunlight. Yet this most revealing moment unfolded during solar conjunction, when the object slipped behind the Sun and out of every Earth-based telescope's sight. Perihelion arrived not as a spectacle, but as a chapter written behind a curtain of radiance. The eclipse was not of the comet, but of our ability to witness it. Instruments on Earth stared into brilliance too intense to penetrate, leaving a gap in observation at the moment when clues mattered most. Astronomers accepted this with a familiar patience. They understood that geometry determines what can and cannot be seen. Atlas travelled through the brightest region of the sky, unobserved yet deeply felt. Silence became the only available form of measurement. Spacecraft near the Sun held the faint possibility of changing that. Parker Solar Probe, enduring fierce heat, carried sensors capable of glimpsing passing dust or transient streaks. But its mission was shaped around the solar wind, not interstellar visitors drifting through sunlight. Any encounter with Atlas would be incidental, hidden inside a sea of charged particles. Solar Orbiter faced similar constraints, its cameras tuned for the corona rather than comets. For a moment, hope rested on chance. No official word came from either mission. There were no confirmations, no images, no calibrated data sets hinting at a fleeting silhouette crossing the solar limb. Yet absence does not mean emptiness. The Sun radiates complexity, and spacecraft capture overlapping waves of information. Somewhere inside, this data still unprocessed, still waiting. Atlas may have left a faint fingerprint. The waiting for verification became part of the story itself. Meanwhile, models filled the observational silence. Some predicted a gentle brightening as deeper ice met sunlight. Others suggested structural stress, perhaps subtle. Fragmentation, perhaps none. Without direct observation, none of these models rose above the others. Perihelion became not a moment of discovery, but a meditation on possibility. The comet moved forward, and theory followed softly behind, shaped by constraints rather than certainty. As Atlas curved around the Sun, the solar gravity tightened its hold briefly before releasing the object outward again. During these hours, sublimation likely reached its peak, sending vapour cascading into the coma in brilliant invisible waves. Jets may have awakened, dust may have lifted, the nucleus may have warmed and cooled in cycles unseen. All of it occurred in a place where light overwhelmed sight. The universe often hides its most intricate work behind its simplest barriers. When the comet reappeared from behind the solar disk, telescopes hurried to reacquire the returning glow. The first measurements showed continuity rather than rupture. The brightness was steady, neither dramatically heightened nor sharply diminished. If Atlas had fractured it did so with a subtlety that escaped broad detection. The visitor survived perihelion intact, its form still whole beneath layers of dust and gas. Spectroscopy offered gentle clues. CO2 continued to dominate, but faint signatures hinted that sunlight had reached deeper material. Slight adjustments in the coma's texture suggested new vents may have opened, allowing ancient compounds to breathe into space. Nothing in the data defied physics, nothing demanded drastic reinterpretation. Instead, every reading affirmed the same truth: Atlas remained consistent with itself. The dust tail illuminated in the early morning sky carried a slight asymmetry, as though shaped by fresh activity. A soft bend in its structure implied uneven heating, or a newly exposed region on the nucleus. Astronomers traced these shapes with calm curiosity, knowing each deviation mapped a chapter of the unseen perihelion. Light curves, dust angles, and gas ratios became tools of reconstruction archaeology, performed on a celestial scale. Attention soon returned to the orbit. If perihelion had altered the trajectory even slightly, the change would emerge as a quiet shift against predicted ephemerides. Astrometric measurements compared new positions with models built months earlier. The numbers aligned almost perfectly. Atlas continued forward along its gravitational path, undisturbed by solar proximity. A stable orbit after perihelion suggested a resilient structure, reinforcing the idea of a nucleus more massive than first imagined. This ordinary motion held its own beauty. Not every interstellar visitor must provoke astonishment through chaos. Some reveal wonder through stability. Atlas passed through the corridor of fire without drama, carrying its form unchanged, its orbit unbent. The cosmos often expresses its elegance not through spectacle, but through quiet endurance. The comet demonstrated that endurance with every measured coordinate. As November unfolded, the comet drifted outward into cooler regions. The coma thinned gradually, dust trails softened, and gas production fell into a quieter rhythm. Each observation felt like the soft closing of a door behind the event we could not witness directly. What happened behind the sun would never be known in detail, yet the aftermath carried its own clarity. Continuity became the quiet answer to an unobserved question. Perihelion in retrospect became a lesson in limitation. It reminded astronomers that even in an age of extraordinary instruments, moments of cosmic significance can still occur beyond reach. It showed that knowledge is not diminished by unseen intervals. Understanding grows in the interplay between observation and absence. The sky does not reveal everything at once. Some truths arrive slowly, shaped by patience rather than immediacy. As 3i Atlas continued outward, its light shrinking with distance, perihelion transformed from a scientific event into a philosophical one. It invited reflection on the nature of discovery, how much of astronomy is built not on continuous vision, but on fragments, reconstructions, and the willingness to accept what cannot be seen. The comet carried its hidden moment forward, etched into dust, leaving us to follow the story through gentle traces. Tonight, the interstellar visitor moves steadily toward darkness again. The memory of its sunward passage lingers not in the data we captured, but in the silence where data could not exist. And in that silence lies a quiet reminder the universe is not obligated to be visible. It reveals itself in its own time, in its own ways, offering wonder even in what it withholds. As November turned toward December 3rd and thus, Atlas continued its slow retreat from the sun, drifting into cooler regions where the coma began to thin and activity softened. The interstellar visitor no longer glowed with the intensity of perihelion. Instead, it faded gently like a lantern carried into distance. Observatories followed this dimming with quiet persistence, knowing each new measurement might be among the last available. The sky held the object delicately as though preparing to let it go. Brightness curves revealed a steady decline in activity, subtle and unhurried. Dust production decreased, creating a tail less defined and more feathered at the edges. CO2 still dominated the spectrum, but its release fell into calmer rhythm as solar heating waned. Atlas seemed to settle into a natural cooling cycle, revealing no sudden outbursts, no dramatic shifts, only the slow unwinding of energy gathered in its brief approach to our star. What changed now were the shadows, not the object. Spectrographs across the world collected their final detailed readings. Cyanide signatures remained stable. Nickel vapor diminished slightly and water vapor declined as expected with decreasing temperature. Nothing contradicted earlier observations. Nothing demanded reinterpretation. Instead, the data converged slowly, forming a portrait of a quiet interstellar body, carrying a chemistry shaped in a distant system. Each spectral line now felt like a thread woven into the larger tapestry of its origin. The orbit too traced its exit path with unwavering calm. Ephemerids matched observations with satisfying precision. No deviation hinted at internal stress or rotational imbalance. Atlas behaved like a coherent, stable nucleus, heavy enough or uniform enough to maintain its course. The lack of non-gravitational acceleration, once an open question, now rested gently in acceptance. The outbound trajectory spoke with clarity, where earlier measurements spoke with uncertainty. In the outskirts of the inner solar system, sunlight weakened until the coma began collapsing closer to the nucleus. This contraction created a more compact glow around the object, making it appear sharper but dimmer. Telescopes adjusted their exposure times, stretching their capabilities to detect the faint presence. Observing Atlas became an exercise in patience, requiring long exposures and careful processing. The fading itself became part of the story, a natural reminder that every celestial encounter is temporary. International observatories coordinated their final campaigns. Arrays in Hawaii, Chile, Spain, and South Africa track the object across different latitudes, stitching together a last coherent record before Atlas fell below detection thresholds. Each facility contributed a final note, a spectrum, a light curve, a positional fix. In these contributions, the scientific community demonstrated its quiet unity, a global effort to follow one small object across the sky. Atlas inspired collaborations simply by continuing to exist. By mid-December, the comet became difficult for amateur observers, requiring large apertures and dark skies. Its magnitude dropped toward the edge of accessibility, and its motion slowed perceptibly in the night sky as distance increased. For many, this marked the symbolic end of the event, even though professional observatories continued tracking it. The object slipped gradually from public view, becoming again a faint whisper of light known mostly to those who followed its deeper story. The scientific questions it raised, however, remained. Why such unusual ratios of carbon dioxide to water? Why such minimal acceleration despite sustained outgassing? What type of planetary system creates a body with such chemistry and structure? The absence of final answers did not suggest failure. It reflected the ongoing nature of scientific work. Atlas carried with it the imprint of an environment we may never know, directly a memory of formation conditions far from our Sun. As Atlas moved toward the boundary where detection would soon be impossible, astronomers reflected on the arc of the entire encounter. It arrived quietly, revealed anomalies gently, and departed without spectacle. Its significance lay not in dramatic behaviour, but in subtle deviations, ratios, grains, trajectories that reshaped expectations about interstellar objects. The visitor did not challenge the laws of physics. It expanded the landscape those laws describe. By early 2026, Atlas would fade beyond the reach of most instruments, becoming a dim trace among the background stars. Its path would carry it back into interstellar space, where it would drift for millions of years before another encounter, perhaps in another star system. What we recorded data spectra brightness would remain as its footprint, the only trace of its passing through our small corner of the galaxy. The rest of its story would continue far beyond our observation. In the silence of its departure, a gentle truth settled across observatories. Not every cosmic visitor is meant to be fully understood. Some arrive to broaden our models, others to challenge assumptions, others simply to remind us of scale. Atlas did all three. It offered the gift of uncertainty, the beauty of incomplete knowledge, and the calm reminder that discovery is not an event but a process. Tonight, 3 Atlas drifts outward, carrying sunlight on its dust and questions in its wake. Its presence grows fainter, but its influence remains shaping how we will study the next interstellar object and the next after that. In its quiet leaving, the universe repeats a lesson. Astronomy has always known everything passes, everything returns to darkness, and in that darkness, wonder endures. As 3i Atlas drifted toward the cold edges of the solar system, its glow softened into something almost indistinguishable from the background stars. Observatories followed it, while they could, tracing the faint line of motion across the dark. The object no longer carried the bright halo of perihelion. Instead, it moved with the subdued elegance of something returning to its natural state. The sky around it grew quieter each night, as though accepting the visitor's slow departure. Researchers compiled the final data sets, spectra, light curves, dust measurements, each now part of a record that would outlast the object's visibility. In conference calls and quiet offices, the last measurements were compared, calibrated, and folded into evolving models. Atlas offered no final twist, no late anomaly to shift interpretation. What remained was a tapestry woven from months of observation, some threads, bright, some uncertain, all meaningful. Its fading became part of the story. In the scientific archives, the early anomalies remained points of reflection. The carbon dioxide dominance, the powdered ice grains, the cyanide signatures, the metallic vapour, they did not resolve into a single explanation. Instead, they formed a constellation of clues pointing toward a world, with conditions different from any we have studied. Atlas carried its birthplace and its chemistry not in a way that solved mysteries, but in a way that deepened them. The unknown lingered with quiet dignity. The orbit too settled into its long, outbound curve with gentle precision. No deviation from gravity appeared, confirming the object's stability after perihelion. Its path mirrored the calm with which it had arrived months earlier, entering the solar system as a messenger of distant processes and leaving as a reminder that the universe often reveals complexity without spectacle. The solar system left a faint imprint on it, but it departed essentially unchanged, a wanderer moving beyond our reach. As instruments reached their limits, observers shifted from measurement to reflection. The event had been extraordinary, not because it delivered dramatic revelations, but because it invited a new relationship with the unknown. For many scientists, Atlas reaffirmed the value of patience in discovery. Not every answer arrives fully formed. Some take years to interpret, others remain unsolved, shaping our methods rather than our conclusions. The interstellar visitor became part of the evolving language of astronomy. Its departure also highlighted the collaborative nature of skywatching. Telescopes on different continents, orbiters around Mars, spacecraft near the Sun, all contributed fragments of the story. No single instrument captured the whole. Instead, understanding emerged from the collective. This mosaic approach reflected the reality of modern astronomy. Knowledge is not gathered in isolation, but in the quiet intersections between many perspectives. Atlas passed through all of them, becoming a point of connection across the scientific world. As weeks became months, the comet faded beyond nearly all detection, leaving behind only models and memory. Yet its influence persisted. The next interstellar object will be studied differently because of Atlas, its peculiar chemistry, its stable orbit, its hidden nucleus. It shaped questions that scientists will now ask routinely. What conditions form carbon-dominant comets? How common are heavy interstellar bodies? How do we interpret activity without acceleration? Atlas did not answer these questions, it created them. The public too carried its quiet lessons. Many followed the object's journey, reading updates, watching simulations, learning the rhythms of observation. In doing so, they encountered the nature of scientific uncertainty, not as a flaw, but as a fundamental element of exploration. The universe does not reveal itself all at once. It reveals itself in fragments, in echoes, in patterns we assemble slowly over time. Atlas demonstrated this gently inviting wonder through absence as much as presence. When the object finally slipped into invisibility, astronomers marked the moment with a sense of calm rather than loss. It had travelled through our system as countless others surely have before, most unnoticed, most unseen. This one left a trace not because it stayed long, but because we were watching and because our instruments had reached a maturity that allowed us to listen. Its silence became part of the sky's texture, a reminder that the cosmos is always speaking, even when we cannot hear. And so, Three-Eye Atlas continues outward into distances where even our most powerful telescopes cannot follow. It carries with it sunlight on its dust, the memory of our star, and the fingerprints of its own forgotten origin. We remain here beneath the gentle glow of our skies, holding the questions it left behind. Not every visitor arrives to give answers. Some arrive to show us how to ask better ones. Tonight, as its light disappears beyond the edge of what we can see, let the sky settle into quiet around you. The universe is vast, patient, and unhurried, and we are briefly part of its unfolding. Rest now, dreamer. The cosmos remembers, and now, traveller, our path for tonight grows quiet. We have followed Three-Eye Atlas from the warmth of the inner system to the dimming edges of sunlight, tracing every whisper in the data, every silence between the lines. What remains is not conclusion, but a kind of peaceful understanding that the universe rarely gives us answers wrapped in certainty. Most of the time it offers something softer, a hint, a pattern, a breath of possibility drifting through the dark. Atlas will continue outward long after this night ends, carrying carbon from another sun ice, from another age, and a silence we can only observe, never touch. The mystery does not close, it stretches gently like a tide that never fully recedes. And in that unfinished story there is something beautiful. A reminder that curiosity is not a destination but a direction. We are small, yes, but not insignificant. Each question we ask becomes a light, a faint one perhaps, yet enough to follow through the dark. Wonder is its own form of gravity, pulling us forward, holding us close to the unknown without fear. so let the night settle around you now. Let the stars keep their quiet vigil while the universe continues its long patient unfolding. Rest well, traveller. Stay curious. The cosmos will keep watch